Hey, so today we are talking about the different types of space rocks. So we're going to start off by talking about a comet. A comet is a small body of ice, rock, and cosmic dust, which is loosely packed together. It gives off gas and dust in the form of a tail as it passes close to the sun. So you can see over here, this is our space rock over here. This is the center of it, the nucleus. And then there is a tail. We really only see the tail because the nucleus is too dark to see. And then this dust trail, gas trail that it's leaving behind, is caused by it getting too close to the sun. So this video does a good job at showing how essentially each time that it is orbiting around, it's just falling towards the sun, and if you pay careful attention to it, you'll notice that the tail is always pointing the exact opposite direction of wherever the sun is. So the sun's heat and energy moves outward in every direction, but the tail is pointing the exact opposite direction of wherever the sun is, which is pretty interesting. And each time it goes around, it just loses a little bit of that gas and dust and rock. The ice melts a little bit, so chunks of it break off. And actually, this is part of the reason why we have meteor showers. Normally, it's because a comet might be like going past the sun, chunks of it break off, and we can actually calculate how regularly that happens, and that will lead to regular meteor showers that we can predict in the night sky. So that is a comet. So the most famous comet is Halley's Comet. It's discovered by Edmund Halley in 1682. So it was seen again in 1758, 1835, 1910, and 1986. So it's expected next in 2062. So how old will you be during that time? Interesting to think about. That's how long it happens. So what's pretty crazy is I believe that it was discovered by him, but he was not around to see when the next one would be, because obviously, if you're paying attention here, it's roughly 76 years or so in between. So this comic does a pretty good job at showing you that there's a little kid who sees it, and he sees it again as an old man, but no person will be alive to see it three times like that. So Edmund Halley predicted it, right? And then he wasn't alive for the next time that happened, but it did come by, which is why they named it after him. And this is actually where he lived. I just happened to be visiting in Cambridge, in London. Sorry, near London, United Kingdom, and I just saw his house was there, so I was like, I had to pose for a picture in front of it. It's pretty cool. All right, so comet is one type of rock. If you did not, please go back and write down that definition and then add these two definitions as well. So an asteroid is a small, now small is relative. It's very big compared to us, but it's really small compared to like a planet or a moon. It's a small rocky body that revolves around the sun. So it's not large enough to be considered a planet, but it does revolve around the sun still. And most all asteroids are located in the asteroid belt. It's a region of the solar system that almost all the asteroids occupy, and it's between the orbits of Mars and Jupiter. Originally, when they were calculating how all the planets were revolving, they noticed that there was a lot of mass in between there, and they thought that if you add up all that mass, it was just another planet. But instead, it's almost like a really, really, really small planet, but separated into all these different different chunks of rock out there that we call asteroids. So almost all the asteroids are located in this area. Now, when I was growing up, I assumed that every single time you would see, if you look over here, they're so clustered closely together, and that's why I thought if you were like navigating between them, that you would potentially run into them really easily. But all of these are like on average like a million miles apart. So if you were like driving your spaceship through it, most likely you wouldn't encounter any of them actually. But that's okay. It just shows how big space is. I like this. This is kind of funny. Asteroids are nature's way of asking, how's that space program coming along? Because, in theory, if we know that an asteroid is coming towards us, the dinosaurs got wiped out by an asteroid. If they had a space program, maybe they could have deflected the asteroid, moved it in some way. We actually have some pretty interesting ideas on paper about how to potentially do this. We've never had to do it before, There has been one experiment so far where we actually crash landed an object crash landed our satellite into an asteroid, and it did move its impact off a little bit. So pretty exciting, the potential for that, and hopefully it's not something we'll ever have to actually worry about in our lifetime. So after an asteroid, a smaller version of that is a meteoroid. So please jot down these two things. A meteoroid is a small rocky body that revolves around the sun. So they're very similar to asteroids, but you can see some of the differences over here, right? Asteroids can be hundreds of kilometers across. Meteoroid, average ones are the size of a pebble. So big size discrepancy over there. These are found throughout space, and these are mostly the asteroids are just found in the asteroid belt. Now, if they come into our atmosphere, this would potentially cause the end of the world. That's what happened to at least we think 65 million years ago. But over here, these typically just vaporize in the atmosphere, and those are called shooting stars, which is a meteor. So that's just a meteoroid that burns up in the Earth's atmosphere. Now, here's where it gets a little tricky. We have asteroids, we have meteoroids, and we have meteors. And they're all really similar to each other in terms of like what the word is. So how do you remember what they are? One trick I like to think of is asteroids and meteoroids are out in deep space. OIDS, out in deep space. So these are out in space, but a meteor is actually burning up in our atmosphere. And then when it lands, it turns into something else. So a meteor is simply a shooting star. Now, they call it a shooting star because it's so bright, and you can see over here how it temporarily lights up the night sky when it broke apart right there. But of course, important to remember, it is not a star at all. Stars are not nearly that close to us. They don't break apart like that or anything. That's just a space rock. It was a meteoroid, but as it enters our atmosphere, by the time it hits our atmosphere, even though our atmosphere is made out of air, it's moving so fast that when it hits the air, it's almost like it's hitting something really solid. And if you don't believe me, think of the next time that you are driving really fast in a car and you put your hand out, and then the wind, right, is pushing against your hand, and it can push it really far back if you're traveling fast. So, think of the space rock traveling incredibly fast. When it hits our atmosphere, it breaks apart just like you saw right there. And that's what causes that image over there. And you can see that I thought this was pretty cool. Depending on the speed that it enters in over here and what the meteor is made out of, it will have different like kind of colors to it. So the last one we just looked at, I think, had more magnesium in it because it kind of shifted towards that color when it came in. Now, if a shooting star, right, comes across over here and it manages to withstand breaking up in the atmosphere, if it doesn't just turn into cosmic dust, then what winds up happening is that a little chunk of rock will land on planet Earth. So if you're lucky enough to find one of these space rocks over here, that is called a meteorite. So it's a piece of meteoroid that reaches the Earth's surface. It tends to be very dark, right? Because this is actually volcanic rock. It was formed, in the early solar system. It's actually pretty much the same age as planet Earth itself. So some of the oldest rocks you'll ever find are going to be meteorites, if you're lucky enough to find one. They could be actually somewhat valuable. You could sell them for potentially a couple $100, depending on how big it is. The larger it is, the more likely you'd be able to sell it. And they're a lot easier to find in areas like here. So think about that for a second before I answer. Why do you think over here would be an easier place to find it? If it lands in an area where, like a volcanic island, it's already surrounded by a lot of dark types of rock. But over here, it really contrasts the white landscape over here with the snow. So it's easier to find in that situation as opposed to, or maybe also in like a place where it's like a desert, like a sand. It'll just be a different color, so it's easier to spot in that way. So that's a meteorite.
Meteorites,
All right, so let's just quickly go over. This is one thing I want to leave you with. You definitely need to be aware of how can a meteorite come originally from a comet. So let's go through it, and this is something I want you to be familiar with. So a comet is a chunk of rock, right? But it also has ice. So the only difference really between an asteroid and a comet over here is that this is surrounded by ice. So imagine that this goes around the sun several times and it loses all of its ice. Okay, now it became an asteroid. So same thing right over here, but maybe now it's just like a loose asteroid that's coming through. So an asteroid is a giant rock, but if a little piece of that rock breaks off, which is what can happen, it can break off of a comet or an asteroid. Now you have a much smaller thing, a meteoroid, still out in deep space. Once it enters in our atmosphere, it starts to burn up. And then if it survives that and lands on the ground, it's a meteorite. So again, this little chunk over here can originally come from a comet or an asteroid over here, breaks off into a smaller piece, burns up in the atmosphere. If it survives, bam, you get a meteorite. And that is the journey that a space rock will take.